Okay. Hi, everyone. Good to be here. So my name is James Heaton. I'm a machine learning engineer at Aurrigo, and my talk today is linking academic research to the AV industry, KTPs, and beyond. So essentially, this is just going to talk about how we as a company use academic research to benefit our business. So just a bit about me. I'm currently a machine learning engineer at Aurrigo. I've been in that position since September of last year. Before then, I was a KTP associate. I'll explain what KTP means later on in the talk, as it's directly relevant to this. And then I've got a master's degree from St. Andrews, and then before then I did my bachelor's in the US at the Georgia Institute of Technology in mechanical engineering with computer science. Agenda for the talk, I'm going to give a brief overview of Aurrigo as a company, talk about some of our ties with academia. I'll go into more specifics, so KTPs, PhDs, and some other partnerships that we have. So Aurrigo are designers and manufacturers of autonomous vehicles. Our headquarters are in Coventry, built in Coventry. We have offices kind of all over the world, USA, Canada, and Singapore. So we have essentially found our niche in the autonomous vehicles industry. We're a small company. We cannot really compete with the big boys like Tesla, and almost every major automotive manufacturer today is looking into their own autonomous solutions. So our niche is low speed enclosed environments. So that's first and last mile transportation. So this usually means short transport, maybe in so first and last mile means essentially from a bigger area of transport, like a train, to your final destination, whether it be the office or a stadium or something like that. Baggage handling, that's where a lot of the money is coming from at the moment. So baggage handling in airports, and simulation as well, so simulating airport operations. So I'll go over some of our vehicles. Our first vehicle that we created was the Autopod. So it's, as I said, it's for first and last mile transportation, and it seats up to 4 people. We have a larger version of this called the Auto Shuttle, which seats up to 8 passengers. I say it's currently in use in the Czech Republic. It's literally just finished this week. The vehicles are coming back as we speak, but we've just undergone a project in the Czech Republic. So this is our Auto Dolly. This was our first baggage handling vehicle that we developed. So we trialed this initially in Heathrow and achieved very good results, and we are currently operating in Changi Airport in Singapore. We have the Auto Dolly Tug, which is a bit similar to the Dolly, except it's got more towing capability, so it can tow up to 3 manual towing dollies, each having a ULD. So a ULD means unit load device. You'll see them at airports. They're essentially just crates that carry your baggage. And we take these from the baggage handling area to the planes. I've got a short video describing how this works. If I just hit play.
Be alarmed if you see driverless vehicles when you next fly through the airport. They are part of a trial to use autonomous vehicles to transport your baggage between the terminal and your plane. These vehicles will first pick up a unit load device filled with your bags and autonomously move off to the aircraft stand. Safety features ensure that the vehicles will recognize people or obstacles on the road and avoid them. They are programmed to autonomously maneuver busy roads at the airside. At the stand, autonomous mechanical arms transfer the ULD directly onto the joint container pallet loader. With automation, drivers can be freed up to work on other critical functions and improve the airport's overall efficiency. Try to catch a glimpse of these vehicles the next time you travel.
So I don't know if any of you are planning a trip to Singapore, but we are, as said there, we're currently operating in Singapore, so you will be able to see us operating there. I love Changi Airport. It's world renowned as one of the best universities. Oh, am I feeding back? Okay, no, here we go. Yeah, Changi Airport is world renowned. It ranks as one of the best universities, best airports in the world. Singapore is massive on automation, not just in the air side, but kind of in all areas, so public transport and basically everything that they can automate, they are trying to automate, which is great for us. Don't want to do that again. So this is our most recent vehicle. This is the Auto Dolly Tug Mark III. So this is the most recent iteration. So as opposed to the previous vehicles, which have to be kind of driven normally up to your baggage handling area, this can perform crabbing, which is basically sideways movement. So the vehicle itself kind of comes down onto kind of caterpillar tracks and enables side-to-side movement rather than just forward and back using regular steering. And this allows it to also what's known as tank turn. So essentially it can spin around on its axis by sending power in different directions to the caterpillar tracks. It can spin around, perform many more complex maneuvers that our vehicles couldn't previously do. And again, it's got robotic arms which can load and unload ULDs. This is off to Singapore on Thursday. So I've been working today and we'll be working tomorrow some final checks with the camera systems, getting that all set up and ready to go. Another vehicle we have is the Auto Patrol. So this is based off our Auto Pod. It is a security vehicle. So this is aimed for monitoring large campuses, for example, airport security. So the aim is you could have a fleet of these vehicles traveling around the area that you want to monitor, and you have a single person in a control room somewhere who can see the camera feedback from these vehicles and maybe even issue commands or warnings through the vehicles themselves. I've just got a quick video of the Auto Patrol. Very dramatic music.
Introducing the Aurrigo Auto Patrol, a vehicle to automate your security and reduce employee costs. Auto Patrol has been designed to enable autonomous, unmanned, remote security and surveillance. It has long-range, high-resolution stereo color camera, a tethered drone option, and LiDAR image detection. The vehicle does not require a driver or an operator to be physically on board, which will in turn decrease overall operational costs, and through the automated technology, improve the accuracy of security risk detections. The Auto Patrol can be operated autonomously or with onboard employees. Aurrigo Auto Patrol.
Okay, so that's our vehicles. I think, we've got one more vehicle, which is the Auto Deliver. So this is essentially a delivery vehicle. So it contains sort of chilled and unchilled containers. Essentially, it's similar to your Ocado or Tesco home delivery vehicle, except it's autonomous. This is just a prototype. We haven't gone into production on this just yet, as we're focused on our Changi operations. And then finally, we do airport simulation, so which is essentially a digital twin of an airport. This was born out of requirements for Changi Airport, where we had to model the airport and prove that our vehicles could operate autonomously in the environment, and that worked well. And we thought, why not scale this up to model the whole airport worldwide? So our system shows clients how savings can be achieved by electrifying their fleet. It also shows you how the fleet travels around an airport, what kind of congestion can occur. Say if you decide to close a gate, how that affects both foot traffic and vehicle traffic to the stand. So we are obviously working with Changi Airport, and we are also developing a simulation system for Grand Rapids Airport in Michigan, USA. So the main reason I'm here is to talk about academia and industry. So we have a number of university partnerships, not just here in the West Midlands, but kind of all over the world. Just some examples of our clients there: WMG at Warwick, the University of Ottawa, and University College London, just to name a few. So one great way of getting involved with academic research as a business is the Knowledge Transfer Partnership, or KTP. So this is what I was part of when I graduated and joined Aurrigo. So it's a 2-year project that links a graduate with a business and a research institution. So I was the graduate, the business was Aurrigo, and the academic institution was Aston University. So it's funded by the company and the university and Innovate UK in a 1/3 split. So it's great savings for the business, as we only need to provide 1/3 of the funding. So my KTP, as I said, was with Aston from 2020 to 22. It's got a fancy title, which was to develop and implement a sophisticated machine vision solution for autonomous vehicles in low-speed environments. Essentially, what this means was the company, before I joined, was not using any sort of computer vision at all. It was solely reliant on LiDAR for all of its operations. The benefits of cameras is that they're cheaper and more readily available, but the difficulty comes in getting the information out of the box. So a LiDAR can give you a point cloud. You can plug it in. It'll give you a point cloud there and then, whereas with cameras, you need kind of sophisticated software in order to be able to do depth perception, object detection, and that was the whole point of my KTP. So I worked with 2 academics from Aston. Some of you may know them, Dr. George Bogiatsis, who I believe is at Loughborough now, and Dr. Luis Manzo. So the company's requirements were that they wanted to achieve a computer vision solution. Luis and George provided me with the advice and the resources in order to achieve this, and then it was up to me to implement. So this image is an example of one of the things I worked on, which was monocular depth perception. So this is creating a 3D depth, well, this is a point cloud, so a 3D point cloud of an environment using single cameras. Molecular depth estimation was kind of just on its early stages when I started. It's since developed a lot more, and I'm going to go into that in a bit, as we have been working on that in various other ways. But I showed that molecular depth estimation could be possible, and that it was a benefit to their business because usually stereo cameras are used for depth estimation. Stereo cameras by design require 2 separate cameras in order to calculate the disparity and therefore the depth. 1 camera, monocular cameras, you only need 1, so that's a saving of half on all your cameras if you were to implement a purely monocular-based approach. I do have a video of the KTP. This might be a bit long. I'll cut this off once if it goes on too long. We'll see what happens. My name is James Heaton, and I'm a machine vision engineer here at RDM. RDM has been in business for about 30, 40 years. They've recently been making spoke parts for other companies in the area, such as Aston Martin, Jaguar Land Rover, and recently launched a sister company called Aurrigo, which are designers and manufacturers of autonomous vehicles, ranging from 4-seater pods to 10-seater shuttles. They're usually used for first and last mile transportation, and they also have a third product, which is the auto dolly, which is designed for autonomous baggage handling at airport.
This is a very innovative project because it's essentially trying to take an existing autonomous vehicle platform into higher level of autonomy. So what we're trying to do is to eliminate the need for a human sort of supervisor to be there when things go wrong, essentially. So we want the pod to be able to make those decisions autonomously without any need for humans to be present.
A lot of our competition either are the manufacturers of the vehicles or from operational actually side of it. As a company, we took a decision to actually bring this all in-house. So all of the vehicles are actually manufactured, actually in Coventry, and we have engineers here currently working on that.
KTP is a self-contained project between a university and a company in a specific industry. And I'm a KTP associate, so I've been brought in to complete a particular project, working with both the academics at the university and the management team here at RDM. Prior to me joining RDM, I had been using lots of different kinds of sensors on their vehicles, and the purpose of this KTP was for someone with some machine learning experience to come in and develop a camera-based system to be able to detect objects and control vehicles. So at the start of the project, we set out to achieve a few things. The first was to develop a simulation environment. That has been completed, and now the next step is to look at developing the camera-based perception systems using machine learning. The aim is to make these vehicles safer, cheaper, and more reliable. So that only stands to improve the standing of Aurrigo going forward.
I think the biggest challenge has been for us academics has been to get in terms with the level of scientific rigor and safety features that need to be built inside these algorithms. Because it's all fine and nice when you're just developing a simple little prototype. When you're actually implementing something on a live vehicle that will be released amongst real people, you cannot afford anything to go wrong. So for us, proving that the algorithm does what we wanted to do was quite a challenge.
Working with both the industry and academics means more support whenever I have a problem.
For a place like Aston, this type of ethos is was almost built in to the fabric of the university. So we have had quite a lot of involvement with industry almost from the very beginning. All of the work that we end up doing in terms of research either has a very, very strong applied segment or sort of leads towards some strong application area. Which means that with all of the work that we do, the end user, the end system that is going to be built is always in our minds. So the nice thing about these KTP projects is that it takes this idea to the next level. So they fit very well with our understanding of what research is really meant to be doing, meant to be solving real problems.
Just being able to prove that you can generate data. I'll leave that because I'm quite anxious for time, so I'll just move on to the next slide. Hopefully that was informative for you. So the direct benefits of the KTP was that, again, academics, they saw their research being directly applied to an industrial setting and they gained valuable data. This is an example of just a simple LiDAR camera calibration I performed as part of my KTP. So that's essentially finding the transform between your LiDAR and your camera, projecting your point cloud data into the image frame to get ground truth depth. So this was how I got ground truth data for training some of our machine learning models. We have the image and we have the depth in that image. And then from there, we can build our perception systems just using cameras. Again, the company received a great boost to their autonomous capabilities, i.e. the introduction of cameras. And this was a third of the cost if they were to hire me myself for a 2-year project, as the KTP splits that financial requirement among Innovate UK and the university. Me personally, I gained valuable experience at an autonomous vehicle startup company, and I was offered a full-time position, which I'm here now upon completion of the KTP. Also, quite a few indirect benefits from the KTP. So it directly strengthened our partnership with Aston. Aston purchased one of our autopods. I'm not sure if any of you guys will have seen it running around, but we have a couple of projects in the pipeline to develop solutions for our pods. And as a result of Aston having our pods and being directly able to work on these vehicles, their solutions and the research that they come up with are directly, uniquely tailored to our vehicles. We continue to provide funding to Aston PhD students. I'll talk about this in a little bit. And also, I can give this talk. If I wasn't part of the KTP, I wouldn't have met Nathan, who introduced me to BrumAI. So PhDs, we've been working over the time that I've been at Aurrigo. We've had PhD students sort of come and go. One PhD student has just completed a work placement with us. He was doing a PhD at the Aston Photonics Institute, working with LiDARs. LiDAR is still very important to us, even though we have the camera system. We still use LiDARs a lot of the time. And one of the difficulties with LiDARs is working in the rain, in adverse weather, especially working in Singapore where it rains heavily quite a lot of the time. We want our vehicles to be able to run as effectively as possible. So he developed a solution for an automatic rain cover for LiDAR. We also have another Aston student, Kieran Saunders, who's working on following up from what I did during my KTP monocular depth estimation. So this is his poster that he's presented to conferences. I won't go too in depth into monocular depth estimation, but the main aim of his project was creating a robust monocular depth solution that handles adverse weather. So a lot of work has gone into creating the training data. So lots of augmentation with various different weather patterns, using not only just computer graphics, but also GANs to generate these augmented images and feeding that into the network. And his research has provided a solution that's not only better for adverse weather, but can also perform just as well, if not better, from an octave depth on clear conditions. So another way we work with universities is with European deployments. So we had currently completed a partnership with University College London, working on deploying our auto shuttles around Europe. This was a project to see not only how our vehicles perform in old cities such as Prague. So Prague is an old European city, lots of cobbled streets, very different environment to where we've done deployments before, which is the new town of Milton Keynes, which is obviously 20th, 21st century development and has wildly different layouts, and the types of roads you see in Milton Keynes are vastly different to how you'd operate in Prague. So that's been going extremely well. And as I said, this project was led by University College London, and we received funding from the European Institute of Innovation and Technology. Just got quick, this is just a time lapse of our auto shuttle running around in one of the business parks in, I think this is Brno in the Czech Republic. It's always interesting to see, you can see people wondering what the hell it is that's coming towards them, getting out of the way, taking pictures, etc. But this is an example of a route that our autonomous vehicles do around an amusement park or business park, ferrying passengers from one side to the other. Yeah, I think that's it. So not only Europe, but we also work with organizations and universities in Canada. So we had almost exactly a year ago, we IPO'd on the AIM Stock Exchange. We're actually awarded Best Newcomer just last week following that successful IPO. And as a result of this, we want to expand, but in order to expand, we also want to be able to source the best talent. So we have signed a industry collaboration agreement with the University of Ottawa, which gives us access to the university's resources, but also enables students to work on autonomous vehicles to supplement not only their academia, but this benefits us as whatever research and projects they are working on are directly tailored to our vehicles rather than our competitors. So in conclusion, we're not going to just throw money at academia just for the sake of it. We want to see a tangible benefit to us as a company. And it's even better when we can receive external funding. Obviously, the cheaper we can make something, the better. And when someone else is willing to pay for it, we're not going to say no. So if you are working in business, or even if you are coming towards the end of your degree and you want to get involved in industry, KTP is a great way to do that. So from the business side, you don't need an existing contact at university. This is all handled by Innovate UK. So if you go to Innovate UK's website, you can contact them and they will give you a representative to discuss your project with them, and they will partner up a university with you, as well as help you find the associates. And as I said, successful projects foster a healthy working relationship between the company and the universities. That's definitely been the case for Aurrigo, and has been the case for many successful KTPs over the years. And that's it. So does anyone have any questions? Yep. Oh, yes. Yes, with WMG. Yes. Yeah. So this was a partnership that started actually before I joined the company, but we still have our vehicles with the WMG branding on in Coventry. Yeah. Glad you saw them. Any other questions? Yeah. Future plans for Singapore is, well, our aim is effectively to take over their baggage handling operations. So we're in a trial stage at the moment, which is continuously adding more vehicles to Singapore. And we have sort of milestones that we have to complete in terms of what the airport want us to be able to do. So the first step was just navigating the airside autonomously. The next step was being able to bring bags onto the vehicles. Currently, we are trialing loading and unloading for non-serviced flights. So we have an airplane that we can work with. The next step would be to service live flights. And then once that's successful, it would be to kind of scale that up and start serving multiple flights simultaneously.
So when you say service live flights?
As in, so currently we are bringing our ULDs from the baggage handling area to the plane, but that plane isn't going anywhere. That's just for testing. When I say live flights, I mean taking actual people's baggage and putting them on the plane, and the plane goes. Yeah.
How much does a baggage buggy cost?
I can't speak to the specifics, but fairly expensive at the moment, just because they are prototypes and new vehicles. I would say around £200,000 for one. Yeah.
I do have a question concerning your security concerns as the owners of these assets. So sometimes you see these videos online with that little delivery robots out in the streets that have been severely beaten up, right? So what kind of security concern or security measures are you taking for such an expensive asset to not be treated like that?
Well, currently, I can't really speak as to what we have on the vehicles themselves, but the nature of our operations sort of provides that security. So with our baggage handling vehicles, we're operating on the airside. So you need security clearance even to be able to access the airside. So it's a very controlled environment. And I can't think of many examples where even just regular vehicles have been kind of vandalized by someone working at an airside. It's just the nature of our operations is beneficial in that way. We don't have to worry about that so much as other companies do.
You don't get that in Singapore.
Oh, no, yeah, even in Singapore, exactly, yeah.
Yeah. So I wonder how fast can the car moves?
So at the moment, it's really, I think it's limited to 20 miles an hour. I mean, all airports have a speed limit of either 20 or 30 miles an hour. We are operating in the low speed sector. We are not concerned with traveling at 60, 70, 80 miles an hour. That's just not a concern for us.